if we know the break date, we denote the tau here as the date of the break. And then we can make this binary variable called dummy t of tau, and it's 1 if the date is after the tau date. Let's just write this down. We have the time variable here, and we have a tau here, and maybe we are starting our data set at an arbitrary period 0, t equals 0, and then this tau variable, this dt of tau, or not of t but of tau, let's do that correctly, and this is actually 0 for all the observations here, and then it's 1 for all the observations here, and including this observation here. So this is a dummy variable, which is 0 prior to the break and 1 after the break. And as an example, we have the autoregressive distributed lag model 1, 1, which means that we have 1 lag of the y variable and 1 lag of an x variable. And this, if we are trying to investigate whether or not there is a break in this model, then we have the ordinary ADL 1, 1 model in this line, and that would be the intercept times a coefficient on the lagged y variable plus a coefficient times the lagged x variable. And to test for the break, we can check the intercept for a break, and this gamma naught would then be the change in intercept from beta naught to beta naught plus gamma naught. So gamma naught would then be the change in intercept, and of course you could test this by using the like a t-test or an f-test to test whether or not this intercept change is different from 0. And you can also test whether or not the slope on the lagged y variable is changing by looking at the gamma 1 coefficient on the lagged y variable times the dummy variable. So this variable here would then contain all the lagged y variables for dates after the break, and it would contain the value 0 before the break. And likewise, this variable here, which is the dummy variable times the lagged x variable, would contain the x value for dates after the break, but 0 prior to the break. So this gamma 2 coefficient would then be the difference between the slopes or the slope on the x variable prior to the break and after the break. Our null hypothesis is then that these coefficients on the changes, they are jointly equal to 0. And this because this model allows for changes in both the intercept and the two slopes. So this joint hypothesis can be tested by using an f-test, and which just means that you can use the test function in Stata. It's important to note that in our ADL11 model, we are testing for a break in both regressors, so in beta 1 and in delta 1, and in the intercept. You could actually just skip one or both of these variables that you have created, and then you would test the remaining combinations of the dummy variable and the dummy variable times a regressor. So you can decide yourself what kind of hypothesis you are going to test, and just leave in the variables that you would like to test.